Hello and very good afternoon to all of you. My name is Sohail. I'm co-organizer of Google Developer Group Nagpur. This is the Android 11 meetup we actually you can say waiting for. And as you have seen, in June, Android 11 beta has been launched, and quite new features and privacy changes and updates have been there in uh, Android 11. So today we have speakers not only from the different country but the different continent, and we are actually pretty excited about this session. Without delaying further, I would like to call Jitin Sharma from Bangalore, India. He is currently Google developer expert, and he will going to share about what's new in Android 11. So
Hi.
over to you, Jitin.
Hi. Yeah. Can you add my screen to share? Yeah. Hello, everyone. Welcome to this session about what's new in Android 11. Let me just introduce myself. My name is Jitin Sharma. I work as an Android engineer at Project India, and I'm a Google developer expert for Android and also organizer of the Android meetup. Right now, I'm not in Bangalore. I'm in Noida, staying at my parents' house. Most of us have also moved around from city to city as since this pandemic started. So, but yeah, these online meetups are all we have to connect with each other right now. So, yeah, let's get to the session. So, Android 11 is right now in beta, as most of you must have heard. By September, October, uh, it should be stable by September, October. A lot of you might be trying out the beta from the, let's say, emulator, or if you have a Pixel phone. So I'm going to talk about what sort of behavioral changes you can expect in the Android OS ecosystem as we move to Android 11, as well as what new APIs are available since Android 11, and what improvements in tools and libraries have been there. So first of all, UI. Let's see what Android 11 brings to the table when it comes to UI. So one of the first thing Android 11 has done is it has kind of change the window inset APIs. So window inset is something which is available in Android from a long time right now. So with Android 11, the whole API has been kind of rewritten to give you a better idea of what kind of content is available on the screen window and how you can get inset data around these things, whether it's IME, status bar, navigation bar, something like that. So how do you get these insights? Is you use the existing listener set on apply window insight listener, which allows you to view and insights on it. Once you get the insight, you can then find out which type of insight is available. So window insights has a type. So for example, if I take the type IME, now I have an API which allows me to tell whether a keyboard is visible or not. So I just check insights what is visible, and I know whether the IME keyboard is available or not. Once this is visible, assuming that keyboard is open, I can get insights of this using get insight method, which allows me to determine, the size of the keyboard and what content of the screen the keyboard is occupying. This was not something which was present in Android till now, and handling keyboard was kind of an hassle. But now there is a very straightforward API to get this data, and you don't have to. Earlier we had to use like global on layout listener over the whole activity review to basically get an idea when the keyboard is opening and react our UI according to it. That is the second thing which window inset is also solving, which is IME animations. So as I told just now that IME animating your UI as keyboard opens or not is kind of difficult right now. There is no straightforward way to do it, and this is quite needed if your application is input heavy. It has a lot of forms or something like that. So with Android 11, you have ability to react to these changes. Basically, you get the data as the keyboard is opening, as well as you can drive the keyboard animation, which means you can actually force the keyboard to open through your UI. These are the two examples. The first one is the animation where system is opening the keyboard, but you get a callback from the system on how keyboard is being opened, and you know you can animate your UI to create a fluid motion. The second one, you are actually forcing the system to open the keyboard. So you get the controller and basically you can force the IME to open. So this gives you a larger control depending on the animations of your application, and you can then open or hide the keyboard accordingly. For the first case, you can just use the window insert animations dot callback, which can be applied to edit text. So this callback gives you multiple methods such as progress, on start, and on end. This allows you to basically get an idea when the keyboard is started opening, and with the progress you can get the insets. It's a continuous callback which you will keep on getting. And based on these callbacks, you can accordingly animate your UI to go up and down and create a fluid motion across the whole screen. With a controller, what you can do is instead of system opening the keyboard for you, you now take the control from the system and you open the keyboard depending on the. This will mostly be coupled with the situation where your animations are like this. So in this case, what you can do is just take the window inset controller and then call control window inset animation. You can define the type of inset and then you can define interpolator also. So interpolator essentially will tell the kind of motion which the keyboard should open. It could be linear, it could be path interpolator, depending on how you want to animate this. And then you can get signals for cancellation or when it's finished. So then you can use this signal to make changes to your UI as well. There are other types of inserts also available. For example, the type.ime is used for keyboards, but you do have type.display cutout and type.system bars. Display cutout allows you to get inserts around notch if the phone has a notch. Notch is not something which is dynamic like a keyboard which may come in. Notch is always there because it's physical. But system bar could be dynamic, so system bar could be the navigation bar on the bottom. So some phones may have navigation bar which could hide or come back. So you can use those also to basically animate your UI using the type system bars. This is a sample which is provided by Google in the user interface sample in the GitHub repository. So you can look at the whole code which I showed in the previous slide is available there, along with a lot of other use cases which you can go through. Conversations. So conversations is something which has also changed a lot in Android 11. Now, if I look at my phone or any other phone, we do use our phones a lot to conversate with other people, whether it's through WhatsApp, Twitter, Slack, or something like that. And we want to be alerted when someone is trying to contact us, and these have kind of become important part of our lives. Right now, conversation notifications are lost in the sea of notifications which you have on your phone because there might be a lot of apps which might be trying to get your attention. So the first thing which Android 11 does is that the conversations have a separate space in the notification panel, so you can and they stay on the top, so you can directly go to there and
Jitin, just a small issue. Your voice is somewhat not clear.
okay. Let me just come closer. Let me just go ahead for a slide and then let me know if it's clear now.
Sure.
Sure. Yeah. So conversation now has a new space, as I said earlier. So what conversation also allows you to do is change these priorities of these conversations. So you can have a alerting priority or a silent. So if you have multiple conversation in the pane, then you might change the priority of one conversation, let's say this one, and it will move to the top, and you might be alerted easily for this conversation. Similarly, you can make other conversations silent also, and then you will not be alerted for those conversations. How about now? Is it okay? Hmm. All right, I'll continue. So let's say you are building a chat application, and you want to basically have your application in the conversation space in Android 11. So it's very simple to do. So assuming that you are already using messaging style notifications in your chat app, so you will already have this person API inbuilt. So you can create a person. Now you can create a shortcut info using shortcut info builder. This is also an existing API to build shortcuts, app shortcuts in your Android application. What you do new here is you set a person, set long live true, and then build a shortcut. You push the shortcut to the shortcut manager compat, and then you create a notification, messaging style notification. So this is now necessary for your notifications around conversation to be in the conversation space of notification bar. You can set the shortcut here as the shortcut ID and then just build it, and then you have the notification in your conversation panel, and then user can basically change the priority of your notification as per his own convenience. Okay, I think the voice is fine now. Cool. Moving in the same direction as the conversation API, we now have bubbles. So bubbles allow you to have resizable activities which can be minimized and maximized, and they are available on the system window, like the image which I'm showing you right now here. So bubbles was available as a developer option in Android 10, and they are now a stable API in Android 11. It was kind of a replacement of the system alert window, which a lot of applications like Facebook Messenger and other applications were using to show bubble kind of UI. But system alert window is not a right solution for it. Bubbles API is a solution which is targeted for this use case, and they are now stable and available. Bubbles are also created using notification API. So if you want to have a resizable activity like a bubble, the first thing which you need to do is in your activity, you need to create a resizable activity as true. Once you have that, you can create an intent and a pending intent similar to what you do for notifications. Here again, we use the shortcut info. So shortcut info we explained in our previous section. So similar APIs you have to use when you work with bubbles. And here in the notification, you just create a bubble metadata with a builder where you can pass the shortcut info.id, and then just push the notification using notification builder. You just have to set the bubble metadata and the category, and then your activity should be available as bubble. Now user can just click on it to minimize and maximize it, and then it should be available. The sample of bubble is available in the same repository for the URL which I shared earlier as a user interface sample. So there is a project called Bubbles Kotlin which you can look into it, and it will allow you to take a step with the bubbles. Privacy. So yeah, Android 11 has a lot of privacy change, and they are probably gonna break a lot of apps. So yeah, privacy is one of the big things which has been going in Android since few of the releases. Even Android 10 introduced a lot of privacy changes. So from a distance, these are the privacy changes which are available in Android 11. They're like data access auditing, which allows you to audit the kind of data your application is accessing. Background and foreground service changes, especially around location. There has been restrictions introduced. Package visibility restrictions. So packages are now like kind of restricted. Not everyone can access all the packages in the app. Similarly, scope storage and auto reset permissions. So these are also there. I will not be going into details of this because there is a session just after this session around privacy. So Divya Jain will be taking that session, and she will go into details of these things. So stay tuned for that session. Developer goodies. So let's see what Android 11 has for us developers. Wi-Fi debugging. This is probably one of the favorite feature because my phone still refuses to connect to my laptop. So yeah, so whenever wires are a hassle, and ADB wireless has kind of been there in Android since starting, but it was through ADB, and you had to configure TCP ports and something. Your phone never directly supported it. But now with Android 11, there is a native framework support for ADB wireless. So what it allows you to do is that given your phone and your laptop are in the same network, you can just turn this setting on, ADB wireless, and then connect your phone. In Android Studio 4.2, there is a feature which is basically targeted for this only. It allows you to basically generate a QR code in Android Studio and then scan that QR code by your device, and then they will automatically get connected. So if you have downloaded Android 4.2 Canary, you can try out that feature. So it should be available. So now you can basically wirelessly debug, yeah, and you don't have to hassle with all the cables. Nullability annotations. So nullability annotations are quite important, especially in a Kotlin code base, because platform types can end up giving you runtime exceptions if they are not properly handled. So like nullable would be, since Kotlin compiler forces nullability. So right now, if you access nullable and non-nullable incorrectly, you will get errors. But as within the framework, they mark more things as recently nullable and recently not null. It will start giving you a warning. So it's like a warning for you. You know what, this release we are telling you that this will become nullable, this will become not nullable. So you have a time to change all your code base, and from the next release of Android, these will turn into nullable and these will start giving you errors. So this is something which developers can use to basically migrate their code base in a very timely manner. Crash reporting reasons. This is another very interesting API which Android has added. So this allows you to basically query from system why your application was crashed. So this is available in Activity Manager as a function called get historical process exit reasons, and you can send your own package name into it, and you get a historical reasons of why your process was exited. So reasons could be one of these, like you could get a reason like low memory. A system might have killed your application due to low memory, or a crash. So for crash, you might be already using a crash reporting service like Firebase, Crashlytics, or some other service. So definitely for crash, I think we already have all kinds of setup available. But even these crash reporting services find it difficult to detect things like ANR, for which you need to go to Android Vitals. So this API allows you to also tell like when your application had crashed due to an ANR, and you can query it. Apart from this, you also get user requested, which means user might have force stopped your application. So that might be a metric to look into, that user, why user would have force stopped your application. And request reason permission change, which means runtime dangerous permissions of your application was changed in the background, either by the user or system would reset it, as Android 11 can reset permissions for applications. So these reasons also give you a timestamp description. So the reason has a lot of internal variables through which you can basically find out. You can push this data to your own server and then chart it accordingly and find out what apart from crash, like what are the other reasons your application was exited by the user or for some other reason. This is something which crash reporting services may or may not give you. ADB incremental. So ADB command line tool has an incremental mode now. So what the incremental mode allows you to do is it incrementally installs the application, and it's a huge thing for games because games tend to have APKs which are larger in size. Along with data, they go into GBs. So as you can look into this graph for this game, the ADB incremental reduced the time from 68 to 7.6 seconds. So it's a huge difference, especially for games. And you can even do you can just do ADB install and pass an incremental for this. Even if you're not developing games, there are like scenarios where our applications are huge in size. For example, I personally, my own project in my company, the debug APK goes more than 100 MBs, and we often use command line tools to build the application and push it via ADB. So even there, it should help you save couple of seconds, which could be really nice. So it's targeted for games where like sizes are huge. But if you have like a very complicated project like what I have, then this might also be helpful. And if you use command line tools to basically build and install the APK in your device. Behavior changes. So, behavior changes will affect your applications as you start targeting Android 11. But if you don't target Android SDK R in your target SDK, most of the behavior changes will not apply to you, and your application should work fine, except for a few smaller changes. So, the first thing is like, how do you test all these behavior changes? Like, you would like to test. How, let's say, scoped storage will help you or will not help you, or any other behavioral changes around privacy and service limitations, how will they affect you. So the developer preview has an option in developer options of your device called app compatibility changes. It's a UI with a set of toggles. So these toggles represent all the behavior changes which Android 11 has introduced. So you can just turn them on and off, and then you can test your application in isolation. Let's say I just want to test my application on how scoped storage would affect it. So I could just turn the toggle, all toggles off, turn the scope storage toggle on, and then see what areas of my application get affected due to this. So this is a good API to isolate bugs depending on all the behavior changes. And you can do it via ADB also. If you don't want to use this UI, you can just run this ADB command. These things are basically constant names like default scope storage or GWP underscore ASAN. The definition of these constants are available on the Android developer website. Basically, what they do and what they will trigger when you turn them on and off. So you could read through it and then use this to test the compatibility of your application with Android 11. Graphics and media. So Android 11 now has a native support for HEIF images. So this is not a really popular format, but it's gaining traction across the web. So it's a high quality format for having moving images similar to GIFs, but they are very smaller in size and they perform much nicely than GIFs. So animated HEIFs are available via image decoder API. So I'm not sure if you guys have heard of image decoder APIs, but it was added in Android 10 and it has been enhanced in Android 11. It's essentially a replacement for this thing, Bitmap Factory, and it allows a much easier way to decode images. And it's a really nice thing if you have to work with a lot of image processing, because this API has a lot of post processing capabilities as well. So if you want to, let's say, decode an animated HEIF image, you can just create a source from the file. You can then decode into drawable. If it's a image is a moving image, then you can just cast it as animated image drawable, and then just do drawable.start. So this support is now available. Do check out image decoder API if you have applications which do a lot of image processing work, because this API has post processing capabilities also. For example, if you decode a drawable using it, then you can do a post process on sampling size or target size of that drawable. And there are a lot of things in this API available around the image processing part. There's more. So first thing is 5G. So Android 11 has APIs to basically optimize 5G experience. So this is mostly done via connectivity manager, where you can check the capability called not metered, and it allows you to check whether this mobile has a capability of 5G or not. And then you can also check the this link downstream bandwidth kbps to check whether it's a fast network or not. So 5G is not really available in India right now, but there are handsets which have been launched in recent time which support 5G, and probably the network will do some catch up. So this is something you want to keep in mind for future as 5G support comes, because 5G has a lot of bandwidth and a lot of speed, more speed than 4G. So you could do a lot of network exchange when these capabilities are present in the mobile. Biometric authenticator strength. So in Android 11, it is possible to basically check biometric authenticator strength. Like, it's possible to check the strength of the biometrics in your phone which user has set up. This is really good for finance applications where you might want to access certain parts of the application only when the biometrics have been properly enabled. So you can just have a authenticators dot biometric strong, so which represents a strength which you would like to have. and then you can check whatever the current biometric setup of the user. If it matches that strength, then only you allow the user to go forward. If it doesn't, then you just send an intent, and then user can enroll into that biometric security method, which could be fingerprint, iris scanner if available, or face recognition. So again, I think this is really good for applications which do have like sensitive data, especially finance applications or mobile wallets. So if you want to have strong biometric security available before user can access sensitive parts of your application, then you can use this API. Autofill keyboard integration. So autofill is something which is available in Android from some time right now. So what autofill allows you to do is it creates a drop down in form menus where your users can pre-fill their email IDs, uh, addresses, email addresses, or even like credit card details. So what autofill keyboard integration does is it pushes those suggestions directly to keyboard. So if you have any keyboard application, you would see keyboards do a lot of suggestive words on the top of the UI where they suggest, like email address or words. So the same thing autofill will do. Autofill will allow them to get the data from autofill and then populate in their own UI. Autofill actually doesn't send the data to the keyboard, it sends a UI to the keyboard. So your information which is saved by the autofill, whether it's your email address or your name, it's not actually accessible to the keyboard. It just allows them to show a UI. So here is an example where autofill keyboard integration is done. So as you can see in the keyboard, there is a UI available. So this UI is sent by the keyboard integration as well. It's not something which the keyboard provider owns. Similarly, you can have payment or your address lines. So all of these data which autofill has can be pre-filled in the keyboard itself. So if you are a keyboard developer, so you might want to look into this API. So assuming you have already implemented input method service, you can create something called inline suggestion request. So you can request for these suggestions depending on what kind of suggestions you want. You want email suggestions, or if you're a finance related thing, you might want a suggestion for credit card. And then what you get is response. As I said earlier, you don't really get the data from the autofill, you get a response. So using this response, you can actually put a UI in your keyboard service, and then it will be visible to the user and can be used to autofill in the form data. Resource loaders. Resource loader is another platform specific API which has been introduced in Android 11. What resource loader allows you to do is dynamically resource assets and resources, which could be like drawables, colors, or anything in asset folder. You could even override existing resources given that you download the same keys from the server, or you could add more resources by downloading more resources from the server. There are two new APIs which are added in Android 11 for that, called Resources Provider and Resources Loader. So Resources Provider allows you to load from a directory or even load from an APK. This directory or this APK will be served from your backend, and it will contain a directory structure which will contain all the resources or the assets. And once this has been downloaded, the loader can add the provider, and then the loader itself will get added to the application resources. So once these resources are updated via the loaders, any asset which was downloaded from the server, whenever you request a new asset, it will be the one which was downloaded from your server. Yeah, so let's look at some non-platform things which have been added. Jetpack libraries. So Jetpack has now around 70 plus libraries, and they do releases every 2 weeks. Hilt is available now. It's a new DI framework. It's not a new DI framework. It's a sort of a extension built on top of Dagger to help allow basically it allows you to have an easy setup of Dagger and reduce the amount of boilerplate code which you need while setting up Dagger. Paging is now 3.0. It's written in Kotlin and it's available with coroutines. And Camera X is now in beta. So if you're using Camera X, do go ahead. Jetpack Compose, pretty sure everyone has heard about Compose now. So it's a new UI toolkit for Android. It's reactive and written in Kotlin, and it's being developed in open right now. Android team is taking a lot of feedback on this. So if you do have time, try to check it out and give feedback to the team on how it should be developed. So it's still in pre-alpha. From what I know, it will go in alpha by the end of this year, and let's see how that goes. So yeah, this is all from my side. This was a so in this session I try to give an overview about what Android 11 brings to the table. I have not covered all the changes in to keep the whole presentation concise. So you can always look at the developer documentation where all the API changes are available, and you can look into it. You can always contact me on Twitter here about this presentation or Android in general. So I would be happy to take up some questions right now. Yeah. Okay. If you have any questions, you can put in them in the live comments. Android Studio 4.1 will be released. You mean stable version because beta is already out. I'm not really sure when will they release. We are not aware of the timelines of Android Studio. So, but I think I've been using 4.1 for some time now. The beta is quite stable and quite faster. So I can't really tell when the actual release will happen.
Uh, Guys,
Yeah.
if you have question, just let us know. Otherwise, we will proceed with the another session.
Yeah, if you have questions later in the day, then please send me over the Twitter. My DMs are open. Or yeah, you can ask the organizers.
Okay. So yeah, thank you very much, Jitin, for giving your precious time here. I believe everyone have learned about exactly the new features of Android 11. I personally like the wireless debugging feature. Uh,
Yeah,
yeah. So let's proceed with the next session, guys. We'll take a 1 minute break here, and then Divya will be joining us, who will going to share what Android 11 privacy changes in soon.
sure. Thanks everyone for coming. Bye.
Uh, Guys, we have Divya here. Divya is senior Android engineer in GameTime. She's from California, and she will going to tell us about Android 11 privacy changes. Over to you, Divya.
Thanks, Sohail. Hope you guys can hear me fine. Let me know to the comments if there is any voice issues or anything. So hi everyone, my name is Divya. I have been developing mobile apps for almost 6 years now, and most of it has been in Android native app development. Um, Before I start, would definitely like to GameTime and CBT Nagpur for giving me this opportunity to present this session today. And also to all the organizers, and especially to all you guys for taking out time from your Sunday to attend this. I really hope every one of you is keeping safe and motivated in this new world we are living in. If you're looking to chat technical or have questions or anything I can help with, find me on Twitter anytime. So let's start. So today I'm going to talk about the privacy updates that are coming with Android 11 as announced with the beta launch a month back. And thank you to Jitin for the amazing overview of what all changes are coming with Android 11. Okay, so I'm sure all of us here who have access to a smartphone of some kind have seen the pop-up shown on the screen on apps asking for permissions to access your data ranging from contacts, images, files on your device to even more sensitive data like your location, financial information, phone number, etc. And with a simple click of that allow button, it is not difficult these days for an app to figure out most of the information about you. Now, allowing these permissions is not what's the problem here, but the actual thing is think about is that more access to data there is, the more probability of data breaches and security issues. And since India is one of the largest markets of smartphones, now is the crucial time to actually figure out and understand the risks that comes with giving indiscriminate access to your data and how to minimize these in the apps that you as developers develop. So today we are going to talk about what and how the new Android 11 release, which has been enhancing upon the earlier OS version, has new features to ensure user security and give users more control over protection of their own information. So this is a broad overview of these new features and updates in Android 11 that ensures that the OS is more resilient than before and allowing the users of your app to have more control and transparency of their data. We'll talk about each of these in detail and also look at what's the best way to ensure that your app abides by these features and ensure that there are no breaches or how to migrate and include these changes in your app. So with Android 10, and you can also mention, one of the major changes that came about was that by targeting your app to Android 10 or higher, the app is by default given access to the external storage scope limited by app-specific data. Now, whenever we develop an Android app has two kinds of storages available. One is its internal sandbox storage, and the other is the external storage on the device, which can be the SD card or the actual storage available. So now, with the Android 10 change, the of scope storage, it ensures that the user has more control over their files and limits the data that the app has access to in this shared external storage instead of a broad reading writing power. So this also allows for the apps to have unrestricted access to their own app-related data without explicitly requiring the storage permission. Now, Android 11 further enhances the scope storage performance by giving even better protection to user data in externally stored app data. So some of these enhancements, for example, include updated UI for storage access framework that ensures users are more aware of where and how the data of your app is being stored. Also, it enables raw file paths for native libraries and media files, and it also provides improved APIs to read and edit these media files in files. So now, if your app already targets Android 10, you can set a flag called Request Legacy External Storage Flag, which lets you opt out of the scope external storage system till you update the app based on the use case property. But with targeting Android 11, this flag is automatically ignored and scope storage is enabled by default. So what do we need to do to migrate your app for scope storage support? A is the app uses the legacy storage model and targets Android 10 or lower. The app actually might be storing data on the external storage, which will not remain accessible once the scope storage is available. So we need to ensure that before targeting your app to Android 11, migrate all the app data to app-specific directories before enabling anything. Also, in some specific use cases, even after upgrading to Android 11 and the scope storage model, the user can retain access to the old data if you set a flag called preserve legacy external storage to true in your manifest file. Also, in order to test your current app for the scope storage and how it works with it, irrespective of what version of NCK you're targeting, there are two app compatibility flags that you can test it with, which are default scope storage and forced native scope storage. So from 11 on Android 11 onwards, calling the method get external files directory automatically gives you access to the directory that the OS created for your app specific data instead of the app creating its own directory. Also, for consistency and convenience, the Media Store API, which actually provides you access to all the media files on your device, like the photos, videos, etc., now comes with added methods, include methods like create write request, etc., which you see on the screen, which lets you modify and access media files related to your app and perform batch operations on them. And this is a slightly complicated topic in my perspective. So if you're looking for more details as to how to test your app with scope storage and enable it, I've included a link to a YouTube talk by one of the Google developers who's given a more deep insight into about scope storage and the new way of uh, storing data on Android devices. So go check that out for sure. Okay, so talking about permissions, with Android 11 comes the user ability to specify more granular permissions for sensitive things like location, camera, and microphone. Now, this is made by a change in the permission dialog shown to the user, which earlier used to, with Android 10, came with an option only while using the app, now has an additional option called only this time, which means that allowing this, the app is granted a temporary one-time permission. So now your app has access to the data only for a certain time, which are determined by the conditions on the screen. So once you allow device location for your app, the permission will exist with the app only till the app activity is visible, or basically the app is in foreground, or if a foreground service is launched, or for a very short time after the app is put into the background, or until the user revokes the one-time permission. Now, the best part of this is that if your app already follows the best practices of requesting runtime permissions when needed, you don't need to make any special change to incorporate this only one-time option, because the Android OS and with 11 will automatically take care of it. Now, another thing to note is Android 11 also discourages requesting permissions which have been previously denied. So if the user has clicked on deny here again and again, it is treated equivalently to don't ask for permission again. So just to reiterate, we said that if the app also follows the best practices for requesting permissions, then we don't need to make any change. But what are the best practices? So they basically include three steps. A, for ensure that you are checking for permission every time before performing an action that requires it. And don't depend on shared preferences or caching or local storage, because that can easily go out of sync with the system state. So every time you perform a code, make sure that you have the permission for it. Also, if you are asking the user for permission, provide clear information and more information to the user about why your app needs that specific permission, because that will ensure that the user is more comfortable with that permission. And also, apps should be designed to gracefully handle the denied permission scenario and still provide a subset of the functionalities to its users. Now, if the user, there's also another thing, which is if the user haven't interacted with your app for a long time, the system makes the data secure by resetting the sensitive permissions which user had earlier granted at one time. For example, reading phone numbers, etc. So as before, as said before, for this also you don't need to make any changes as a developer if your app already follows the practices of requesting or setting for permissions, then the feature of the app is accessed. If the permissions are reset for the app because the app was not used by the user for a couple of months, the user will be notified through a notification. So basically, the whole idea here is that the OS is taking the responsibility for user data protection rather than leaving everything for the user. Now, there might be a use case where the user expects your app to keep working in background and might not want the permission to be auto reset. For example, if your app periodically syncs data, which needs to be still required even if the user doesn't use it. So now in this case, in the settings of the app, there is an option for the user to set the flag to not auto reset the permission. So basically, what you can do is launch the intent settings dot action application detail settings to direct users to these auto reset app settings and make sure let the user decide whether they want to enable the flag or not.
Divya, just pardon for interruption. Your voice is somewhat not clear. So can you please check from your side?
Um, okay. Is it better now?
Yeah, it is now.
Okay, thank you. All right, so now in Android 10, also one of the in Android 10, back in Android 10, one of the interesting result was that when users were introduced to uh, the permission, asking for access of location only while the app is in use, more than half of the users preferred to select that rather than granting location access all the time. So with Android 11, obviously that one-time permission access is even more important for location access, and it enables users to be more comfortable enough to give the permission. Now with Android 11, though, there is also a change as to how a feature in your app can request access to background location. Basically, you need to ask for access incrementally. So with 11, if a feature in your app requests for background location and another permission at the same time, it will throw an error. And so there is no separate button to grant permission for background location. The user should basically select allow all the time option, uh, and then only the user will be given access to the background location. And also ensure again to display a UI which clearly explains the rationale behind why your app needs the background location access. So as long as you follow these practices, you don't need to make any special code changes to follow for the access to the background or the foreground location. Now, the other thing that came with Android 11 privacy changes was package visibility. Now, Android 10 or earlier, an app could query the full list of packages which are installed on the device, which is the majority of the use. In majority of the use cases is absolutely unnecessary. You hardly need to know what all apps are installed on your device. But with Android 11, that freedom is no longer available. With a new tag called queries in your Android manifest, you need to actually specify in your Android manifest which apps you might need access to. And by the system of least privilege, only those apps will be visible to your app. Now, within this queries tag, you can specify the apps required by either specifying the package name, as shown on the left here, or by specifying the intent signature. So after specifying these queries, you can use package manager method query intent activities to get the apps installed on the device, filtered based on the packages or intents that you mentioned in your manifest. So in conclusion, if your app needs to interact with any other app, you need to explicitly mention in manifest file whether it's launching any of their activity or starting a service. Now, there also might be a rare case where you still need to query and interact with all the apps installed on the device. Now, Android 11 has you covered for those rare cases as well. So you need to include a permission called query all packages, but this might be useful only in specific limited use cases. Now, if you still want to ensure user privacy, only include the absolute essential apps that you need to interact with in the manifest so your app works appropriately. One thing to note here, though, is that you don't need to include an app if you're using implicit intent to interact with it. So including the queries in the manifest is only applicable for explicit intents. Also, Android 9 introduced the restriction earlier that an app can access your camera or microphone only when it is in the foreground. With Android 11, there are even more restrictions. That is, if your app accesses this kind of data in foreground service, you need to include these in an attribute called the foreground service type, which is in declaration of that service in Android manifest. And you can see the example. So in this example, basically, starting this service means you're specifying that this service would need access to your location, camera, and microphone as well. Now, data access auditing. So Android 11 has a new feature called data access auditing, which basically provides, as a developer, insights into what private user data your app is accessing. So which makes your apps more privacy centric and ensure no unwanted data access. Now, to incorporate this auditing, you register the app ops manager on op noted callback, which then listens to events and then performs action as a result. Now, what kind of events are these? These are basically, this callback is called if your app code accesses private data or if a dependent library or SDK code accesses private data. Now, as you can see in the code here, in order to do the data audit logging, determine which component of your app potentially accesses data of some sorts. And in the on create of that method, implement the callback logic as shown here. Now, with the help of this tag trace, which you see as part of the parameter, it's easy to determine the source of the data access. Now, let's say you have a multi-purpose app which potentially has more than one use case where data is accessed. Now, in order to more logically and conveniently determine which part of the app the data was accessed in, you can also create something called an attribution tag and apply to each of these parts where possibly data is accessed. And the good part is that these attribution tags are returned as part of the objects that are passed to the onNoted method of the callback, which lets you trace the source of data access even more effectively as a developer. So in this example, when this activity is accessing the location of the app, before that, we've created an attribution tag called locate on map. And now this tag will be passed to the onNoted method of the onOpNoted callback. And you as a developer figure out the source of the data access within seconds. So that was all, in conclusion, that was all the privacy changes that came with Android, that have been announced with Android 11. And I think that's all from me. Let me know if you have any questions. Otherwise, a big thank you for everyone listening.
Thank you very much, Divya, for having here. Guys, if you have any question, just put it on comment section. Divya will be happy to answer. And you can also reach out to her on Twitter. She will be, you can say, clear your doubts there as well. Okay, cool. Thank you, Divya, for
Thank,
everything.
thank you.
Okay, so guys, Akshay will be joining us very soon. Let's
Hello.
Akshay.
Hi. Let me share my screen. Done. Oh, are you able to see?
Yep.
Is my voice also clear? Or
Yeah. Clear.
okay, perfect. Okay, so hey everyone. What did you say?
No, please proceed.
Okay, perfect. Hey everyone, it's super exciting to see you all, even with so many crazy things happening around the world. Welcome and thank you for joining. I'm Akshay Chordiya. That's my Twitter hashtag. If you have any questions, just feel free to also reach out to me on Twitter. So I'm based in Berlin, Germany. I'm originally from Pune, India, Jai Maharashtra. I work as a under developer at Clue, which is a female health company over here, and I'm also a Google developer expert for Android. And today, like, we are going to talk about modern Android development. Now, remember, like, modern Android development is actually a loose term, and every year there are like additions and removal to what modern means. Over the years, this has been like getting better and better and more concrete from Google, and also being more opinionated. So before we begin into like what modern Android development is, let's look at like how far we have come on, and like what things have been released in the past. So the first release was SDK M3, that is like milestone 3, where the developers could start building apps using Java programming language. The platform APIs were like available, and at that time developers used to use Eclipse, which is open source for Java and other programming languages, with the plugin called as like Android development plugin. And so this was and these tools were great initially, but slowly they become like bit old, and they had like a lot of overhead, and that's why like, there was a need for modern tools and APIs to fulfill the growing needs of the developers. For example, like in 2014, Android Studio was launched. Since it was harder for the Android team to customize Eclipse in the way they want, for like developers to experience and get all the amazing tools they want to provide, and that's why they moved to Android Studio. Similarly, as like developers started continuously using Java, they faced like a lot of problems, and it was a bit verbose, and developers wanted to have something modern, like modern language programming, lambdas and everything. And that's why in 2017, Google like officially announced support. Even before the official support, some people were already using Kotlin, um, but like in 2017 it became official that uh, the Kotlin is a language for Android development. Then the architecture components were added in 2018. This was actually like the start of modern Android development, like being opinionated, and like Android team providing their opinion and recommendations for how to build Android apps. Um, and now since then, architecture component has been moved to like Jetpack. We will also see like what Jetpack is later in the slides. And then there was introduction of app bundles. We will also see what that is. Okay, so in a nutshell, like what Android development means is like it's like a set of tools, APIs, and the language, and also the distribution technology provide like recommended by Google. So this is like recommendation. Of course, you can always choose what you like, but these are like recommendation by the Android team to help developers be productive and like, create better apps that run across billions of devices. So this modern Android development is based upon like four pillars. First language, tools, APIs, and distribution, and then the foundation. The foundation meaning the Android OS and the Play Store itself. But let's look at these 4 things, starting with language. So so in the modern Android development, like Kotlin is one of the biggest thing. So the timeline of Kotlin looks something like this. So in 2016, there was like 1.0, where people already started using it, and some of the companies around the world already had started using Kotlin. And in 2017, Google saw that like developers are loving it, liking it, and then they made Kotlin as like the officially supported language for Android. And since then, the Android team has moved to like being Kotlin first, like providing libraries which are like specific to Kotlin, giving first class support to Kotlin, which means like documentation, etc. And then they also announced, so Kotlin team announced coroutines, which is like a way of doing asynchronous programming, kind of like RxJava, something like that. Which is now also like the preferred way or the recommended way of doing asynchronous programming on Android by the Android team. So we are pretty much here right now. So why Kotlin? So Kotlin has a lot of things, but in a nutshell, it's like super expressive, which means like there's less boilerplate code. In less code, you can write such a nice expressive code, which is like super readable. It also provides safety, which means like the null pointer exceptions and the type safety basically is like super nice, so that it helps you catch issues even before, like during the compile time rather than the runtime. So which is like super helpful because you don't want to lose your sleep over your app crashing when people are using it. Third is like interoperability. So this is one of the key thing which made Kotlin so successful, in my opinion. So interoperability means like you could already start using Kotlin while you had Java. You didn't need to like delete all your Java code and rewrite in Kotlin. You could like slowly, gradually like transition to using Kotlin in your app code base. So your app could have like 50% Kotlin, 50% Java, and you could slowly move to 100% Kotlin. And the fourth is like structured concurrency. This is again which I talked about, like coroutines, Kotlin flow. It made like doing asynchronous programming super easy, especially on Android, which is why like Kotlin is like a whole set of amazing language. So this is one example like of the. So this is the example of based upon these 4 key things, 4 pillars. So if you look over here, like the bundle type is now marked as like with a question mark, which means that it can be nullable. This is what I meant with the type safety. So because of that, like you're able to handle like anything which can be null during the compile time itself. Second is like Lambda. So like Kotlin is a modern programming language, hence it supports all the modern all the modern features which all the modern languages currently support, which is lambdas, functions as first class citizens. So you don't need to write those new click listeners and something like that. You can just write in them as lambdas. You can also write extension functions. So extension functions are basically so they are like functions on top of like the pass. So let's say you have the string class and you wanted to have a function to check if the string is an email or not, or like want to capitalize the string. And so this is super hard because string class is final, you cannot change it. Using extension functions, you can add any function to an existing class, which is like super amazing and just feels like this new function is part of string class. So these extension functions are super amazing. Yeah, this templating is one of the nice features. Then you don't need to write getters and setters. Like, I mean, technically they're written by Kotlin compiler, but you can just access them as a property now. So it's like you don't need to do like get floating action button, then background and listener or background and list. It's super easy now using property. Also, it has improved the speed, like in terms of development, like people are able to like write code faster, and they write concise and catch bugs even before they are like shipped. So it's like super nice. So since the official announcement of since Kotlin been official language, 60% of the professional Android developers use Kotlin, and over like top 70% of Android apps on the Play Store contain Kotlin code, which is super amazing. And so these are some of the initiatives by the Android team for Kotlin. So on the tooling side, they have added a lot of lint checks to help us like prevent us doing some anti-patterns in the code. There is also dedicated compiler team to help like improve the compiler to make it faster. This dedicated compiler team is also at JetBrains because like they started this language, so they are also like constantly improving the compiler and making it faster and better for us. And also on the other hand, there is a compiler like a dedicated compiler team in the Android team which like does optimizations on Kotlin compiler specific to Android. So one of them is like R8 and D8 optimizations. Like improving the annotation speed is one of them. Then there are also like some of the initiatives by Android team to make using Kotlin much nicer experience in our day-to-day life. These are like annotating platform APIs. Like that means basically since all these platform APIs are written in Java, and when you write the Kotlin code, Java doesn't provide if the variable is going to be null or not null. So all the platform APIs by the Android team were annotated with @nullable, @non-nullable, and also like recently nullable and recently non-null. So these four, so that when you use those platform APIs from your code base, you will be aware that these are Java APIs and they can be null or not null. So this is super helpful when you're using Kotlin. Also, like they released a library called as Kotlin extension library, which is also part of Jetpack. So this library like improves the platform API. So this is outside the platform releases. So no matter like Android 11 comes, 12 comes, 13, whatever. These are up like separately categorized. For example, these are like extension functions which we talked about before, and like so you would generally use this extension function. So what the Android team did is like they collected all of these and just provided us in a library called as Kotlin like KTX. For example, there is one function to easily create a bitmap by just passing height and width in the config. Also like simple drawable APIs to like just make your code concise and nicer. Also, like for example, if you wanted to convert a drawable to bitmap, which was like a bit tricky before using like bitmap drawable, now there is just two bitmap function which was added in KTX. So things like that. Even I guess there is like function for toast and snack bar thing, super nice, just making it so they are like basically synthetic sugaring. So it just makes it nicer and readable when you're writing them in their code. Yeah, like Kotlin specific APIs. Okay, so this means like in Room and Work Manager, like the Android team has added support for like suspending functions, Kotlin Flow, supporting Kotlin specific APIs basically, so that when you write your Kotlin code and use Room library, it's like super easy. You don't need to do write boilerplate code or do X things to make them work. It just works now. Also, like paging 3 was written from ground up with Kotlin mindset, which is super amazing. Also, like Jetpack Compose, which Jitin was talking about, it's just gonna change how we write UIs right now. So this is entirely written in Kotlin, and it's like specific for Kotlin. Apart from that, like they added a lot of docs, training, and samples online for you to like check out how to use Kotlin. So if you haven't used Kotlin yet, feel free to check those material out. Also, code labs and courses. There's so much stuff to learn Kotlin for Android. It's just amazing. Second pillar is tools. On the tool side, we all know and love Android Studio. But let's look at a bit of history. So in 2013, Android Studio was first announced. The reason being, previously it was Eclipse with ADT plugin. With Android Studio, the Android team could add like a lot of amazing features and customize the IDE on as they wish and how they want it to be, so that developers could like leverage all the features what they want to give us. Since then, they have deprecated the Eclipse ADT plugin, and they added like the constraint layout editor, which is like super powered relative layout in a way. Then they added support for Kotlin. They added like CPU memory and network profiler, so you can optimize your app and make them like nice and performant, which is super nice actually. In 3.1 and Android Studio 3.1, they added support for D8 to optimize our code. Now, and also they in 3.2 they added like energy and trace profiler, so you can see how your app is performing in terms of battery, how much battery is consuming, so you can optimize your apps to consume the battery a bit less. In 3.3, they also added a navigation editor. This is part of the navigation Jetpack library, which we'll see ahead. In 3.6, there was an introduction of view binding and things like that. This just goes on. Like in 4.0, there was an addition of motion editor, which we'll see. But yeah, meanwhile, apart from that, like Android Studio is based upon IntelliJ, so it provides a powerful code refactoring, and it just gives such a nice UI. And rather than like a command line, so it gives you a nice UI for all the future tools which they want to give us to. And like I said, it was built on top of IntelliJ, so JetBrains is also actively adding new stuff to the IDE itself, and Google is adding more stuff on top of it, which is specific to Android, and this is super nice. And also it has a tight integration with Kotlin and Gradle. It also provides lint check and quick fixes, and most importantly, it integrates with existing and new APIs. So you can always use any type of platform APIs over there. Yeah, and also with every new release, it adds like special features for each Jetpack library. For example, for navigation, there is like a new navigation UI where you can customize. For rooms, there is like database inspector. I think someone was talking in the comments before, I saw, which is like super amazing features. So things like that can be provided through Android Studio. And these are all the improvements which have been happening recently. Third one is APIs. So APIs meaning the Android Jetpack. So Android Jetpack is like a set of libraries provided by the Android team. So this is like, it has like a lot of libraries. I have pretty much 77 or 80 libraries in there. You don't need to necessarily use all of them, but each one is meant for a different use case. I think some of them are like super necessary, like the app compact one to provide backward compatibility. But tons of libraries over here, and the family of these libraries called as like Android Jetpack. So this was announced in 2017. Since then, like there was constraint layout was announced in 2017. Then the architecture components, and then there was announcement of this Android Jetpack, and all the existing libraries were moved to like this Jetpack family. And now it includes a lot of libraries like paging, navigation, work manager, even Camera X, which we will see in the slides ahead. So for example, like the constraint layout, which is like super powered relative layout, it's super nice to use. You can like arrange your layout based upon constraints, and it just produces a flat hierarchy, so it has like super less performance overhead compared to other layouts, and it's super nice to use, of course. On top of that, there was like so motion layout is a type of layout which was built on top of constraint layout to provide to help us do this amazing animations, where like you could specify how the start looks like and the end, as you see in the GIF. And in motion layout automatically like renders based upon the start and end your animation. Basically, it just helps you do some motions. Okay, now looking at the architecture components, generally like when you write Android applications, so this is more like specific to like Android, modern Android development. So when you write Android applications, you always need to like write a lot of callbacks, like handle a lot of callbacks on pause and on destroy. And this is like super painful when you're building Android apps. So you don't need to do this anymore. I mean, you can do that, but you don't need to, thanks to all the architecture components. And now you can architecture. So basically, the thing which we used to do wrong previously was put all our business logic and everything in the activity or our view controllers, basically activity fragments. Now what we do is like we separate that out. On the left side, there is like user interface. So this is all about rendering the UI, the activity, the fragment, the view. So these are here. The only code you will write is about like setting a recycler view, setting the text view, setting the data basically, like rendering the UI based upon the data basically. And on the right side, there is view model, which is also part of Jetpack and architecture components basically. Uh, so in the view model, you would ideally write your business logic, and what the user interface will do is it will observe the data, and whenever there is a change in this data, for example, you have a list of you have an app, a news app, let's say, or like a like let's say WhatsApp, and you're observing for chats in the data, and as soon as there is a new data, like a new chat message comes in and it is stored in the database, the data will tell that there was a change in the data, and the user interface will update based upon that. So this is super nice. It's called as like unidirectional data pattern, um, and it's super helpful to avoid this life cycle issues which we saw before. So in general, the whole app is architecture. The recommendation is to architecture in the way as shown above in the diagram. So basically, you have this activity fragment, which is just your UI renderer. We call it as UI controller, where you have only rendering logic. Then the view models. So view models are the one which are like a sandwich in between your repository and your UI. So repository is the one which contains all the business logic. So in the repository, you would ideally write where to get the data from. So either the data is fetched from network. Let's say you have WhatsApp, you fetch all this chats from the server. So the repository would be the place where you would say that, okay, web service, give me chats or something. And on the other hand, it also talks with the database, so it kind of like communicates between the database and the network web service, and then gives this data back to view model. View model is just like when the activity asks for, let's say in the activity you would say, I want all the chats to show on the UI. View model would be like, hey, okay, you want all the chats, let me get it from the repository, and then repository will actually have the business logic to get that data and give it back to activity. Yeah, and also like if there were any updates in the data, the repository, the callback would go to the repository, and the repository would tell to view model, and view model will tell to activity to update the UI. There is also a sample app. So disclaimer, this is my sample app. This is not provided by the Android team or anything. It's a sample app which I made and actively maintain it. It has the same architecture pattern which I am showing over here, and all the modern Android development tools like Hilt, Dagger, and everything is in the sample app. In case if you want to learn how to build modern apps for Android, I also constantly update that app to reflect what is modern. So this is basically the TLDR of what I said. These all libraries are built to work together. For example, view model and live data are lifecycle aware. So when you close your screen, they would stop updating, or when you rotate your app, they would like stop the network request and not send it again, for example. So things like that. That's what means like lifecycle aware. Yeah, this is basically the same things which I talked about. Yeah, so the navigation component. So the navigation component is another library part of Jetpack family. So this helps in like building, this is like storyboard for iOS, if you have done iOS development, where you can like define all the screens. So you can define what happens when you, press the floating action button in the basic activity, what should happen. So this is also in the Android Studio, you see a really nice graphical interface where you can see which screen leads to where. Let's say you have this onboarding flow, you can define all the connections, which screen goes to where, what data flows from where, which is like super nice for visualization, and also helps in building the whole navigation of the app. The deep linking is also supported by navigation component library. That's pretty much it about navigation. Let's look at Work Manager. Work Manager is yet another library which is part of Jetpack. So Work Manager gives you the ability to run something in the background. So it's not a replacement for Alarm Manager. For example, if you want to run something at a really specific time, like let's say at 9 a.m. or something, for some reason you need to do that at an exact time, then please go ahead and use Alarm Manager. Work Manager is not for you. Work Manager is, as it says in the first point, it's deferrable. That means your task doesn't need to be performed at the exact time. It just needs to be performed with certain conditions and in the background. Then Work Manager is perfect. It is compatible since API level 14, and it supports for like periodic tasks. So you can say that every day at 4 a.m. For example, in WhatsApp, they back up the data at every day in the morning at 4 a.m. So you can set a periodic task, something like that, like at every morning or every certain time, it needs to do this periodic task. It's like a cron job for servers, basically. You can also like chain a lot of tasks or do parallel tasks together. You can run like 3 tasks and combine them and then give their output to the server or something like that. There's also support for that. You can, rather than giving the exact time, you can, a Work Manager takes constraints. So you can tell that if the device is connected to internet, do this task. If device is charging, do that task. If the storage space is not low, then do some operations. So it's based upon constraints, basically. Here's a use case of WhatsApp, for example. So for example, it starts the backup when battery is not low. And when the backup is started, like so these are like constraints. The task is not started until all of those constraints are met. For example, the backup starts when the battery is not low, if the storage is not low, because if storage is low, you cannot save the backup on the device. So you need to check if the storage is not low. Also, like you can specify at what time it should run, like periodically. So this time is not exact because these constraints, if these constraints are not met, it won't run at this time. So when you specify a time, it doesn't necessarily mean that it will run at the exact time. That's why I said, like, if you need something to run at super exact time, just go ahead and use Alarm Manager and not Work Manager. You can also specify that, like, once the backup is ready, the next task can be, if the network is unmetered, basically you're on Wi-Fi, then just upload this huge backup to server or wherever you want to. So this in Work Manager, this logic is defined in workers. So you write a worker and the do work function. In the do work function, you write your business logic, and when the business logic is successfully completed, you say that result is success. That means worker was success. You can also say that retry based upon your business logic. You can say that retry and use exponential algorithm. So Work Manager has all those things already predefined. And like I said, you can set up these constraints that if the battery is not low, you can also set up like one-time request. For example, you wanted to send something to the backend when the device is not offline, and it's just one time. So you can just say one-time request. You can also enqueue tasks concurrently. So for example, over here, task filter 1, filter 2, and filter 3 will run together at the same time with the same constraints, basically. So which is also cool. And then you can also specify the whole chain, like run these three tasks together, and after these 3 tasks are completed, then compress, then upload, and you can like you can define the entire chain of operations, which is super nice. Next up is Camera X. So this Camera X Jetpack library was introduced because every manufacturer has a different camera, has different like sets of hardware used for camera, and this was always hard as a developer to build a camera app or to use camera in your app, which supported all these devices. You needed to write bunch of if-else cases, like if Samsung, as usual, Samsung always have the problem. So Samsung do that and blah, blah, blah. So rather than, instead of writing us, Android team decided that they will create a library, and we just need to say that we want to use camera and use Camera X library. And for us, it's like super easy. For them, they handle the if-else. So right now this works by Android API 21. It works almost on 94% of Android devices, which is like seriously really nice, considering how diverse Android is. And also gives consistent output across devices. And it's super easy to use. Now you don't need to write all those if-else loops if you just wanted to write an app to take a photo, now you don't need to worry about all the devices available on the planet. So you can do like a bunch of stuff, like you can use Camera X to provide a preview of camera. You can perform like image processing, basically analysis of image, photo, image editing, and a bunch of stuff like that. You can also use Camera X to actually build a camera app to capture things using camera. Okay. So meanwhile, like also Jitin mentioned, these new these libraries are frequently updated. They have the release cadence. They're, I think, bi-weekly updated. Like every alpha or beta build is bi-weekly updated. There are also like constantly new APIs in development. For example, Jetpack Compose, which is developed openly. Hilt, which is in alpha, which is the new recommendation by Android team for for dependency injection in your Android apps. Paging 3, this is also actively in development. You can always try that out. Fourth one is distribution. This is like Android app bundles. So this was introduced, I think, 2 years ago or something. So we will see what that means in a while. But before that, the problem is like 3 in 10 Android devices have less than 1 GB of internal free space, which is a problem because if your app is bigger, if your size of your app is bigger, people would not install it due to network issues or also like storage issues. Previously, people used to see a lot of these problems when they go to install an app, and Play Store would say that you don't have sufficient storage, and they would need to uninstall some of your apps, which is seriously bad. So basically, if your app is smaller to download, people will also increase the installations will automatically increase. So for example, if you decrease your app by like 3%, 3 MB, you would already see increase installation by 1%. So so which is super nice. So app bundle is a format. So when you look at the legacy side, when you provided a legacy APK, it would like put everything. It was a monolith APK, so everything would go in like all the languages, all the screens, and the images for all the resolutions would put in the legacy APK, which used to be huge. Also, like based upon architecture, let's say this was 12 MB or something, and with app bundles on the right hand side, when you install, so as a developer, it's super easy. You just create an app bundle, you upload it to Play Store, and Play Store would determine your device. So let's say you're living in India, you're using language Hindi. So then in that case, it wouldn't, when you download the app, it wouldn't download other languages for you. This would save a lot of MBs while downloading and also while you install. And also based upon this is based upon 3 things, like the locale, the device resolution, and the architecture, as those 3 things are shown over here. So based upon your specific device, that specific APK is now dynamically provided when you install from Play Store, which saves a lot of APK size on for user and for you. The other part is also like dynamic delivery. This is like extension on top of app bundles. So this is even fancy. So even fancy meaning like, let's say you have an app where you say that after purchasing the premium subscription or something, you want to unlock a certain feature. In that case, you can say that when you unlock, when your user purchases the premium subscription, you can write a certain code using which this new module would be downloaded from Play Store. So it's like basically on demand. So you can like pull the features on demand. This would be super lightweight for users because they get only what they need, not the whole app. So which is nice for developers and also for users. And Android app bundles is already used by already 500,000 apps in production, nearly by 50% of top apps and games, and almost 35% of active installs are through app bundles, which is super nice. And compared to monolith APK where everything was shipped, it just on an average gives you like a 20% saving, 20% like shaving off your APK size, which is super nice for as a developer. You just don't need to do anything, and I just love it. Okay, let's put it all together. All the pillars. So in the language, we have Kotlin. In the tools, we have Android Studio to help us build modern Android apps. On the API side, there is a lot of stuff, basically the whole Jetpack family. And on the distribution, there is Android App Bundle to help you out. And that's it. So this is the link which is constantly updated with all the modern Android development, which is recommended by Android team. Feel free to check it out to read what I have mentioned over here. And thank you. That's it. Unless if you have any questions, just feel free to ask any questions.
I have one question here from Phil.
Okay, so is async task? Okay, so async task is definitely deprecated, and it's no longer the recommended option to do asynchronous programming. Work Manager is not actually a replacement for it, because async task was not. It used to do things in the background, but not when your app was closed or something. So a one-on-one replacement for async task would be using a reactive library like RxJava, or for example, Kotlin coroutines or Kotlin Flow. That is like the one-on-one replacement. But for sure, Work Manager is used to do things in the background, like when your app is not even visible to the user.
Cool. Thank you very much, Akshay. I hope everyone have learned about the modern Android development practices. More of the features are actually added, and I think we have covered almost in this meetup. Akshay, just a small request from you. I believe people are somewhat interested in knowing your journey. So can you please share it with us?
Okay, sure. But journey, like in the sense, like, how do you want to know, like being the GD journey or coming to Berlin?
Yeah, being both. I mean both.
Okay. So actually, I start from the beginning. So I started Android development during engineering, like I think like end of first year, something like that. So I did my bachelor's in Pune, if you know Pimpri-Chinchwad College of Engineering, PCCOE. So I did my bachelor's from there. I started Android like end of first year. I started building like random apps. I have my apps on the Play Store. I just built apps for my own, basically. But turned out that when I built app for me, it was not just problem for me, because people also face the same problems and they started downloading my apps, and that just motivated me to continue that journey. And eventually, I started learning a lot of things. I came across RH components, Kotlin. I started Kotlin even before it was officially announced by Google. Um, and then when I started learning all those things, I felt that I should share this back to the community, and then that's how I started my journey of like giving meetups, talks, and writing articles. I more than talks, I love writing articles and continuing maintaining my sample app on GitHub, which I shared the link in the slides. I can also share over here. Um, so I continued that, um, and then in 2017 or 2018, actually in 2018, I moved over here in Berlin, and that's when I moved over here, I joined Clue. And then I over here I applied for GD. I actually had also applied for GD in India, that it was rejected in first place. Reason, but when I came over here again, reapplied for GD, and I got GD over here. And if you have any questions like how to become a GD, or what are the perks and how the process looks like, feel free to ping me on Twitter, like tag me on Twitter, or reach out to me anywhere on any social platform. Should be good. Yeah. If you have any questions, Sohail, about the journey.
Yeah, thank you very much, guys. For your information, Akshay is also instructor at Caster.io. He have delivered many talks, and if you have any questions related to Android or you can say development, please reach out to Akshay on Twitter. I hope everyone have enjoyed. I guess all the speakers have also enjoyed the session. Thank you very much for having you, Akshay, here, and all the speakers out. We would like to thanks all the community partners who came here and given their contribution in making this event a very big success for us. We will like to, you can say, looking forward a very good events in future, and hope to see guys in upcoming meetup as well. Thank you very much.
Thank you for having me. Bye.